This fourth lesson on integration by partial fractions is about repeating quadratic factors. Here's the example. The integrand can be expressed as a sum of two simpler fractions. We put a linear factor on top of each. So on top of the x squared plus 1, we put ax plus b. On top of the x squared plus 1 squared, we put cx plus d. Same as before, the next step is to clear the fractions. We multiply both sides by x squared plus 1 squared. On the left side, the whole denominator just cancels out. We get 2x cubed minus 5x squared plus 5x minus 5. Move on to the right side. Under the ax plus b, the denominator x squared plus 1 cancels out the square. So we get ax plus b times x squared plus 1. Then under the cx plus d, x squared plus 1 squares cancel. We multiply everything out, then group the like terms. Now we're ready to equate the coefficients. Match up the x cubed coefficients, we get a equals 2. The x squared coefficients, we get b equals negative 5. The x coefficients, we get a plus c equals to 5. Then finally the constant terms, b plus d equals negative 5. So we have 4 equations. This is a pretty easy problem again. We'll do some harder problems in part 5. Combining equations 1 and 3, we find that c equals to 5 minus a, and because a equals 2, plug that in, c equals to 3. Equation 2 and 4, we have b equals negative 5, d equals negative 5 minus b, d equals to 0. Substituting these results into the partial fractions, we find that the original fraction equals to 2x minus 5 over x squared plus 1 plus 3x over x squared plus 1 squared. The given integral can now be expressed as a sum of two simpler ones. The first one is the integral of 2x minus 5 over x squared plus 1. And the second integral is 3x over x squared plus 1 squared. Okay, let's take a look at the first one. How do you do that? It turns out we have to split that into two parts. 2x over x squared plus 1 and the negative 5 over x squared plus 1. So we have 3 integrals to do. The third one is a power rule problem. I'll express it in the format, the integral of u to the negative 2 du. The answer is log of x squared plus 1. We don't need the absolute values because x squared plus 1 is always positive. Minus 5 arctangent of x minus 3 divided by 2 times x squared plus 1 plus c. QED